All right, so let me pull these up. What I'm going to do is I'm going to share my screens here. So I'm going to start off and I'm going to share Microsoft Excel here. All right, so hopefully you guys are comfortable making graphs in Microsoft Excel. All right, and so what I have here, this is the same data table that's on there, except I filled in some heart rates. So what we're going to do, the first thing that we're going to do is we are going to graph heart rate versus speed. So that's the graph that you guys are going to make for the treadmill running, is heart rate versus speed. So your heart rate is on your y-axis, speed is on your x-axis. For the stepping test, you're going to graph heart rate versus the stepping rate. Right? So remember with graphing, so I'm gonna demonstrate here. We're going to highlight our speed column. Now we don't have to highlight the entire column because we're only wanting to highlight where there's heart rate data. So you highlight your speed column, hit Control, and highlight your heart rate column. So now we have both columns highlighted. We are going to insert an XY scatter. Right? We don't need any lines on it right now. Right? So once you click that XY scatter, this is what it's gonna do for you. Now this is not a good graph. Right? So we want to add a few chart elements. We're gonna change the title. So to add chart elements, we click on the little plus sign right there. And we want to make sure we add axis titles. All right, so we're going to have our axis titles there. And so our y-axis, we said, is heart rate in beats per minute. Our x-axis is treadmill speed, and it is in miles per hour. We can change our title. While this isn't, I'm not going to be grading you necessarily on your elements and stuff. We still want it to look good. So heart rate versus speed. All right. Now this is still not what we need. Right? If you look at the graph that's on the paper, you'll notice that I've formatted the y-axis, I've formatted the x-axis, and I've changed the variables. Because what we're trying to do, all right, when we use heart rate, remember these are sub-maximal tests, right? But what we're trying to calculate is VO2 max. So what we have to do is, by using those two heart rates, 110 and 150, we're going to draw a line, and we are going to extrapolate out until we get to our estimated maximal heart rate. And from there, we're going to calculate our estimated maximal workload when we reached that estimated max heart rate. So the first thing we're going to do, again, we're going to format the values on our y-axis. So all you do is you left-click on it, right? It highlights it, and then you're going to right-click on there, and it says to format your axis. Right? Now, what's our lowest heart rate on here? All right, the lowest value is what? 72. So I'm just going to start. I'm going to put our minimum heart rate at 60. All right. So that, you can see that changed it. We don't go from 0 anymore. It starts at 60, right, in terms of heart rate. Now, maximum heart rate, well, we're going to go, how do we calculate maximum heart rate? We're going to estimate by 220 minus age. So most of you are at least 20, right? So at a minimum, it needs to be 200. But what I'm going to do is I'm going to put our maximum heart rate, I'm just going to put 220, right? So there we are so far. Right? All right. I'm going to also change our units. I'm going to change our units from units of 20 to units of 10. Right? And so that's what it looks like right now. Now we need to do the same thing for our speed. So I'm going to left click on speed, and then I will, it's already over here as format axis, but once you highlight it, then you'll right click and it pulls up format axis. What is our lowest starting speed? It's loud. Our lowest speed is 3 miles an hour. Right? Now, our highest speed that we got to is 5.5. But remember, what we're trying to do is we're trying to extrapolate out. And so we need a higher maximal speed than 5.5. So let's just put 10. All right? We're not going to need it to be that high, but just for our purposes, we're going to say 10. All right? Okay. You guys following along so far? All right. So once you have that graph, I'm sure there's a way in Excel to do all this, but I haven't figured it out. Once you have your graph how you want it, we're going to take that graph, we're going to copy it, and we're going to paste it into a Word document. Right? Because once we get it into the Word document, then we can draw lines and things like that on it. All right. So I'm gonna copy it. So copy. I'm going to stop sharing the screen, and then I'm going to start sharing another screen as we. So I'm going to open my Word document, and let's see. I'm going to share an application screen, application window, and I'm going to share my Word document now. And so now that we have our Word document open, I'm going to paste the graph in. All right, so my graph is pasted in there. So if you look at the paper that I handed you, it gives you instructions now on what to do. All right. So letter A, it says draw a maximum heart rate line at 220 minus the age. All right. So the first thing we're going to do is we are going to draw a horizontal line at their estimated maximum heart rate. So we're just going to say that this individual is 20 years old. So 220 minus 20. All right, gives us an estimated maximum heart rate of 200 beats per minute. You guys got that so far? We're good? All right, so we are going to insert in Microsoft Word. You go to Shapes, right? And then a line is right there. So 200 beats per minute, we find it on the graph, right? And then we're going to draw a line all the way across that graph. Right. So we have our estimated maximum heart rate line at 220 minus the age. Again, we said this was a 20-year-old individual. So 220 minus 20, their heart rate, their estimated max heart rate is 200 beats per minute. All right. The next instruction is to connect the final two data points. So these are your two data points where the heart rate is between 110 and 150. All right. So on our graph here, we have our final two data points. We're going to do the same thing. We are going to insert shape. We're going to select a line, right? And we are going to take that line, put it on our next to last data point, and we're going to connect that line through the last data point all the way until it crosses our estimated maximum heart rate line. So you can see I went and just went across. You can stop it right at the estimated maximum heart rate line, or you can just go on across. All right? Everybody good so far? So what we've done now is we've extrapolated out, because remember, this relationship is linear. So if we were to continue to increase the exercise intensity, we would expect the heart rate to continue in approximately that fashion until we reached their maximum heart rate. All right? Does that make sense? All right. So step number 3, it says drop a vertical line down from the maximum heart rate. So where that diagonal line crosses the maximum heart rate line, we're going to drop a vertical line straight down until it reaches the speed. All right. So again, insert, shape, select your line. All right. Now where that diagonal line crosses the maximum heart rate line, we're going to take a line and we're going to go straight down. Good. You guys see what I did there? All right. So now what we assume, what we're doing here is, all right, we're continuing out. All right, we're increasing exercise intensity. We reach maximal heart rate. Well, at approximately what speed on the treadmill would I have reached maximum heart rate if I had continued on? About 7.5 miles per hour. And so again, you don't have to do this, but I just to kind of demonstrate. Right? We're going to take a circle and we're going to just put a little circle or a little dot about right there where that line crosses the speed line. All right. So what we have just figured out is, right, although we stopped at 5.5 miles an hour, right, if we had continued exercising, increasing 0.5 mile an hour every 3 minutes, we would have reached maximal heart rate at approximately 7.5 miles per hour. Have I got that so far? So what's next? All right. So you figured out, all right, if I continue to max, I'm going to reach max at about 7.5 miles an hour. Well, the American College of Sports Medicine has developed equations, estimation equations for treadmill walking, treadmill running, leg ergometry or leg cycling, arm cycling, and stepping. So they have 5 equations. Their running equation, as long as you know the speed of the treadmill and the percent elevation or the grade, then we can estimate oxygen consumption. Right? So all we do now, as you see, letter D there on your sheet, on the front side of your sheet, it says calculate VO2 max using the speed from the graph by putting it into that equation. Your equation is VO2 is equal to speed times 0.2 plus speed times grade times 0.9 plus 3.5. Okay. Now, was there a grade on the treadmill? Did we say anything about grade on the treadmill? No, so it's 0. So that entire part there is 0. So really what you're figuring out is speed times 0.2 plus 3.5. So in these equations, though, it's a little bit tricky. We're used to miles per hour. In this equation, speed is used as speed is put in as meters per minute. So we have to convert miles per hour to meters per minute. I give you that conversion there. 1 mile per hour equals 26.8 meters per minute. So what we'll do, again, I'm gonna type this up here. So we estimated that the individual reached heart rate max at 7.5 miles per hour, right? That was what we said based on our graph here. Reached maximum heart rate and at that speed of 7.5 miles per hour. But to use that in this VO2 calculation, we have to convert that to meters per minute. So the way that we do that is for every 1 mile per hour, that's 26.8 meters per minute. So we take 7.5 miles per hour times 26.8 meters per minute for every 1 mile per hour. And I'm just going to say that basically because what would happen is miles per hour will cross out. Right? And so what we get there is, what is that, 201? Right? That equals 201 meters per minute. Right? Is your speed that you will put into that equation. And so now let's do our calculation. VO2 is equal to 201 meters per minute times 0.2. And actually, I didn't write the equation. Let me put the equation on here. So speed times 0.2 plus speed times grade times 0.9 plus 3.5. So that's our full equation. Right? Now we said grade is 0, so we don't have that grade component there. So 201 times 0.2 plus 3.5. So VO2 is equal to 43.7 milliliters per kilogram per minute. Right? Because 201 times 0.2 is 40.2 plus 3.5 is 43.7. Right? So we were able to figure out what this individual's estimated VO2 max was based on this linear relationship between heart rate and VO2, right? And workload. Are there any questions with that? For the stepping, you do the exact same thing, except there's a different equation. It gives the equation there. And for the on your y-axis, you have heart rate still, but your x-axis is step rate. Right? So you put your step rate on there instead of the speed. Right? We just view it as heart rate versus intensity. Well, speed is intensity on the treadmill. Step rate is intensity on for the stepping there. Okay. I give you that equation for the stepping calculation, right? And you need to know the step rate, which if it's 22 steps per minute, then that's what you put in, and you need to know the step height. Now, we have it in inches in this equation. The step height is in meters, so I give you that conversion, right? 1 inch is equal to 0.0254 meters, so 12 inches, if you chose a 12-inch step, 12 inches is 0.3048 meters. So whatever your inches are, you multiply by 0.0254 to get to meters.